Everybody, I'm Tommy Clayton, an OpenSciEd middle school teacher and lesson writer. Today we're going to take a look at lesson 5 from unit 8.3, which is our forces at a distance unit. This is a nice quick lesson to one day, but it's super crucial because this is the last lesson before the turning point in the unit when we're going to have a larger assessment. So a couple things to check out in this lesson to make sure we're in a really good place to tackle that assessment in the next lesson. So let's check it out. All right, let's remind ourselves how we got here. So we're coming off of lesson 4. We did a lot of heavy lifting in lesson 4. We figured out a lot about the magnetic field, that it has a shape, that there are directions to the forces, and that those forces seem to get weaker as we move away from the magnet or the coil. So in this lesson, we're like, whoa, wait a second. What happens if we add a second magnet? Because we have only really seen that one magnet. So that's what we're going to check out in this lesson. So let's take a look at this lesson at a glance. So one day, it's going to take you about 10 minutes to get set up. There is no hands-on investigation. After lesson 4, you know what? You deserve a break for that. And this one is going to require some devices, though. We're going to use simulation, so students should have access to devices. All right, so let's take a look at how this kind of breaks down. So we have one pretty good sized chunk, and that's really using the simulation. And then the next part of it is going to get us into lesson 6. So really big chunk. And what we ultimately are going to figure out is that when there's two magnets, if the magnets are set up in a way to attract, those field lines seem to connect. And if the magnets are set up in a way to repel, those field lines sort of divert away from one another. There's a particular pattern that we see. So we're going to take a look at 2 key moments in this particular lesson. So ultimately what we figure out is really what the field looks like between the magnet and the coil when things are set up to attract or when things are set up to repel. So by the end of this, we should be in a really good place to draw that field and have a good sort of vision in our mind of what that looks like. So let's take a look at the key moments. We're going to highlight just 2 really important ones in this particular lesson. So the first is part 2 is where we're going to use the interactive. It's going to look a little bit similar to the last time, except we're going to add a couple of pieces to it. So now we get to see 2 different things. We get to pick whether we want to use a coil or a magnet for our second thing. And we are also now able to see strength of forces. So as we move the coil or magnet closer to one another, we can see how those force arrows grow. This is going to be a little bit of a callback to 8.1 when we did some work around using arrows to show the strength of forces. So after we do this simulation and we explore it, we're going to come together to develop models. So first the students are going to work on a model, and then they're going to come together and we're going to kind of develop this class consensus model and capture it in our progress tracker. You want to really help to support students in recalling that what we're drawing represents the arrows of the compass needles. That's what we're seeing in the simulation. And that's what we tested with in lesson 4 using the compasses. So we're not actually drawing a physical thing that's actually there. It can be a little bit abstract for students. So we just want to kind of remind them that what we're drawing is a representation of if you put a compass in that spot, that's what you would see it do. Okay. Students are going to be really unsure as to what happens when things are super, super close when they're repelling. It's really hard to tell in the simulation, and that's okay. So, you're going to do your best with that part to draw what is happening, but totally okay if it's a little bit messy in that area. Okay, so after we use the simulation to do that and we wrap up, where we're going to go into the next lesson is we figured out a lot of stuff. And so we want to use this to explain something new and different. First, we're going to apply this to the speaker, but then we're going to take a transfer task and apply what we figured out to how an electric doorbell works. All right, so a little bit of material management, a couple tips and tricks for this lesson. Really important in this unit, we go to this interactive several times. Each time, though, the link is different because the simulation changes and we add different things. So make sure that kids are not going back to the interactive from the previous lesson. It's a new link, a different one that you need to share. And each time we do an interactive throughout the unit, each link is different because it builds on the previous one. It adds more features, things like that. As we said before, it's okay for the students to be a little bit unclear as to what's happening with the field lines when things get really close. If your students have not done 8.1 or have not worked with this idea of the force arrow and the changing length of it, you may need to do a little bit of scaffolding there. Let them play around with it. Ask them what they think it represents, why it gets larger, and then document that on your class consensus model. If your students have done 8.1, this should be very, very familiar to them. Okay, one last big thing to highlight is the navigation out of this. It's really important that you don't skip this. This is the last moment for you to formatively assess the students before the larger piece in the next lesson. There is an opportunity in the next lesson, but I think it's really important to capture this now. It'll help you make choices about how you go into the next lesson. And so they're going to do this exit ticket. And they're really going to consider some like cause and effect sentences. And sometimes the effect part can be a little bit tricky. So you may want to really focus them on like what they would see. You might even have some props or things like that to like hold up. But the idea is like we want them to really think about like if the magnets weren't actually being held in place, like we put them on the desk or something like that, what might we actually see happening when we brought them close together? And here's where we're looking for kids to say that they might move together or they might shoot apart in some way. Always helpful to give students some sentence starters to scaffold them to help them, especially knowing they're going to do this on the assessment in the next lesson. There are no new words in this lesson to add. And we do have the magnetic field poster that we're going to use. We are going to come back to this in later lessons, but we're going to develop something new that we're going to want to keep. So this is something that'll be likely in their progress tracker. It's something that you can hang on to, but we're going to kind of redraw this as we figure out some new stuff in upcoming lessons. So that's going to do it for lesson 5. I hope you see how useful it can be to put this together and gather that information before the larger assessment task in the next lesson. Come back and join us for lesson 6, and we'll talk more about that assessment and the moments leading up to that.